Welcome to the bane of all existence for coding bootcampers and the ultimate job interview killer. I'll be honest with you, this video is meant to be more of a review or a refresher rather than complete zero to hero networking course. A refresher to me and a training video for my future interns. Today I wanted to cover some networking fundamentals. I'll use a typical home network as an example and talk about some basic network services. I'll also cover network arithmetic. All that has been to a bigger or smaller degree a topic during my job interviews. This is absolute basics for everyone who works with modern-day computers. Well, unless you're managing a fleet of Temple OSs. Okay, absolute first thing you need to learn when you're learning about the networks is the OSI model. Referring to OSI is 19% of network discussions and troubleshooting. Layer 2 issue, layer 7 firewall, and so on. Honestly, you only need to know and feel the first 4 layers. Anything above that is typically in the application scope. So let's cover them quickly. Physical is the electric signals, radio frequencies, or photons sent over the network. You could say those are bits and bytes, but not really. That depends on the medium, encoding techniques, correction codes being used in the transmission, and so on. I want to make this very clear. You are not sending raw data here. It is wrapped around additional error correction codes or modulation solutions specific to the medium of transmission. For example, this will be different from this on the bits and bytes level of actual things that are transmitted. Not to mention that those are completely two separate mediums of transmissions and therefore two separate technologies that are being used for encoding the sent signal. Data link is the second layer. The transmission unit here is called a frame. The most widespread and known protocol here is the Ethernet, but the data link layer has an abundance of other protocols, many of which aren't widely known, but are still frequently used, especially in automation and safety. It can be very fast and has low latency if properly utilized. It can be commonly referred to as the Ethernet layer, but you have to remember that this is not exclusively Ethernet layer. Next is the network layer. We can start talking about packets here and most importantly, networks. Everyone knows IPv4, but other widely used protocols here are ICMP, OSPF, and IPv6. Yes, IPv4 and IPv6 are separate protocols. Not only that, many people forget that ping by default doesn't use IP packets. After that is the transport layer. It implements protocols responsible for end-to-end communication between clients. It can be both stateful and stateless, so as you probably guessed, both TCP and UDP live here. Also, even though TCP establishes a session, it belongs here in the transport layer, not session layer. Now, it gets confusing if you look above transport layer. Honestly, if you ask me, anything above it is an application layer. If you don't want to pass CCNA with flying colors, then it's perfectly fine to view it just like that. One other thing I would like to emphasize is that you might hear phrases like TCP layer or Ethernet layer. But you have to remember that this is just a mental shortcut, and there are multiple protocols that can be used instead of Ethernet or TCP on their respective layers. There is a reason why OSI model is so good at describing networks. The second thing you need to learn is encapsulation. Encapsulation is the next best thing since sliced bread, and it can be explained in a single sentence. Each layer envelops the layer above it. For example, when sending a UDP packet, its header contains information about the destination port. That whole thing is then put into an IP packet, which has information about IP address and can be routed on the internet. But before that, everything is encapsulated in the Ethernet frame, which can send data locally based on the MAC address. And finally, the networking card converts everything into electrical signals, light pulses or radio waves. Along the way, the packet can be de-encapsulated and encapsulated again, depending on what device is processing it. Switches will only decode up to a link layer. Routers and firewalls will unpack higher layers and package them back down to physical, so they can be transmitted further if needed. This is a perfect segue, not to our sponsor, but to talk about different types of network devices. Thankfully, you only need to know two: routers and switches. And God help me if anyone starts talking about hubs. F off. Based on the OSI model, it's really easy to describe those devices. On a very basic level, switch is layer 2 device and router is layer 3 device. You also need to understand that this is a very traditional and basic way of looking at things. There exists crazy devices like layer 3 switches or layer 7 firewalls, but those don't concern us here. I just want you to be aware that the world is big and definitions get muddled when you hit big scale deployments and hardware that costs tens of thousands of US dollars, which has to service operator level traffic. I might do an episode on that, I mean the enterprise network hardware, so subscribe if you're interested. I literally have that hardware lying right next to me, so... Switches deal with Ethernet frames only. They are fairly easy to spot since typically they look super plain compared to routers, and most often have a lot more ports than them. It's worth noting that the cheapest consumer-grade ones typically don't support VLAN tagging, so they're often called dumb switches. What VLANs are, I'll leave for another time, but if you know, you know. Switches can only send and receive data from hosts that are within their broadcast domain. Broadcast domain spans only across a switch or a network consisting only of switches. Routers form boundaries between broadcast domains. Routers allow communication between networks. It can be weird talking about routers and networks and routing tables and how internet works when most people have only this device in mind. Don't get me wrong, this is a router, but it's also doing many other things that often model the picture. Typically, it has built-in modem, switch, and can also perform network address translation, or NAT for short. So its strength lies in combining multiple devices and network services within a single box. And it has to do that, since we are still mostly using IPv4. With the advent of IPv6, those routers mostly will become firewalls because you no longer need to perform NAT, but now you need to worry about your devices not being open to incoming internet traffic, since most often IPv6 addresses are public and routable on the internet. All that sounds great, but compared to a proper router, this device is very limited. A proper router would be able to use BGP protocol and load the so-called whole internet table. But with commodity devices, most often you can only configure two networks, the LAN and WAN, maybe three if your device supports some sort of Wi-Fi guest mode, but most importantly, your LAN network has to be one of those three. These are the so-called private addresses ranges. Let's cover network arithmetic and maybe a bit of history. Those three network ranges have been determined to be the so-called private subnets, and they cannot be routed on the internet, meaning you will never have a server with IP address of 192.168.10.20 available publicly, because nothing outside of its local network will ever route to it. Nothing will explode if you configure your network to be outside of those private ranges, but you will cut off part of the internet that is available to you. Simply speaking, you will not be able to reach websites or services that are under your configured scope. For example, let's assume you've set your LAN network to be 8.8.8.0/24. You will not be able to reach anything in the 0 to 255 range, like the Google DNS service, which is for 8s. Your router, instead of sending the packets to the next router, will think that this network is locally connected and no routing is required. But aside from that, things should work just fine. There is much more that can be said here, especially stuff like, how does anyone know I am not actually 8.8.8.8, which involves BGP protocol or ASN numbers, but I will leave that for yet another video. Now, for the network arithmetic, it is actually super easy. Very often we ask candidates to tell us properties of this network. And typically we get sound answers, but then follow-up is this. Or this. And it's as if the hell has frozen over. It seems the biggest problem is with understanding how the network mask works. But in order to start talking about that, we need to convert everything to binary. I'll show you my method, which doesn't use division, and in my experience I find it way faster. Let's use 166 as an example and convert it to binary. First, write out powers of 2 until the number will be bigger than the one you are trying to convert. The reason I wrote it like this has to do with the fact that according to the convention, we write the least significant bit on the right side. Now, from left to right or from biggest to smallest, subtract those powers of 2 from our number until you reach 0 and write 1 if you used that power and 0 if you didn't. So with 166 it will be like this. 166 minus 128 equals 38. 64 we can't use because we would go into negatives. So the next one is 38 minus 32 equals 6. 16 we can't use, same with 8. So 6 minus 4 is 2. 2 minus 2 is 0, because we also can use 2. And for the unused leftover bits, we write 0. Easy, simple, no division required. Going back to our subnet, let's convert everything to binary. I'll be quick about it since there isn't much to explain here, but you should definitely pay close attention because you can be expected to do all that on paper during job interview, and all in all, you should just know this. Software engineers who say they don't touch network stuff should watch this twice on half speed to make sure it sticks. If we execute boolean AND on address and netmask, we get network address. If we change bits that aren't network ID from 0 to 1, we get broadcast address. Broadcast means that our packet is to be received by every host in the network. Network ID and broadcast cannot be assigned to hosts as IP addresses, so the first usable IP address will be the network ID plus 1. And the last usable address will be broadcast minus 1. So from that we can conclude that the number of hosts that can be addressed in this network can be calculated as 2 to the power of 9 minus 2, because network ID and broadcast equals 510. Those are the basics. Learn them by heart and you'll be good. I know a lot more can be said about everything I mentioned here, but you're probably tired already and I don't want to give you too much information at one time. Do me one last favor and hit the like on the video and subscribe if you haven't already. Next time I'll use hentai to illustrate the internet packet routing.